Hello everybody. Hopefully if you've been watching all the PAiCE videos, you know who I am. I'm Brendan.
I'm Mackenzie.
Mackenzie's working with me, working through all of the data that is coming in through the PAiCE process. We're recording this video because we have observed that there are some common errors and misinterpretations that are being used throughout different workshops. So hopefully if we bring them up here and you watch this right before you start your workshop or your pre-fill, you can avoid making those same mistakes. So we're going to run quickly through each module and identify where the common errors are at. And just a reminder that when you're on your screen, you should go to full screen. And then if you hold control and scroll your mouse, you'll go in and out. So if you're on a projector, you might need to change where you're at, and you can also hide these things into full screen mode so that you can maximize your screen space. So as we work through here, make sure on the B module that you are in the right file. And as we come through, we are starting with S minus. Mackenzie.
So there's a couple of things here. The first of which is just looking at the crops that you've planted and making sure that the seasonality is correct. We've had a couple of cases where some of the crops have been perennials, so tree crops, and they've been put in as seasonal. So you might only be harvesting the crop once, but it might be a little bit different. So just keep in mind to think about what type of the crop actually is and not so much about the harvest.
So the key things here are how many times do you harvest it and how long is it growing in the ground? If you harvest it more than once, or if it goes across more than one season, don't put seasonal, put perennial or annual, so that we can know which seasons the crops relate to. So for instance, cassava, if it's harvested at 2 points during the year, it's not seasonal anymore in terms of the tool. It's annual or perennial, depending on how long it is then in the ground. So anything that is harvested more than once, go annual, and anything that is in the ground for more than 1 year, go for perennial. So that's the major things. And then in the S results. So the point of having this here is that you identify problems that you've put in the data before you move into the next module. So take a second to stop in the S results, have a look at it. Are the major crops there? Have you chosen the right seasons? Do any of these numbers look wrong? So in this case, we have some Egypt data. We can see that wheat in winter and maize in summer are roughly equivalent in terms of value. So you would then ask yourself, is that correct? Is there a crop that is missing that is the most important crop that we know of, and it's not coming out at number 1? And then go back in and check. If you want to quickly look at all of your numbers that you've put in at once, you can go to this S results, S inputs, and it will tell you how everything is calculated and what numbers you've put in. So those are the key things to consider in Module S.
We just want to hop back to the capital S there as well. There is one other thing in here. So just looking at seasonal fallow in the extent of key cropping activities, you really want to make sure that if you have 0% fallow, that there is absolutely no fallow. So that's what that means, is that there is no farming land that has no crop on it. And while that might be the case for some places, just keep that in mind as you're filling this out.
It's generally uncommon that you would have absolutely no seasonal fallow. So think about if 0 is the correct number there. All right, that's our wrap of common errors in Module S. All right, welcome to our continued observations of the data we're getting from Module F. There's a couple key things here. So the first one we want to look at is this marginalized population. So what we're trying to capture here is when we assess adaptations later, we want to check its impact on marginalized populations. As it says here, and maybe there's too much text, so we're getting a bit confused, we cannot have this one involving gender. Women and girls are already captured in the tool as a separate question. So the marginalized population that you put here cannot relate to gender because that's already related, but already asking about women and girls. Make sure that that population also has some relationship to the agricultural lands. So this is generally around a particular religion or caste that is a minority, or a small landholding population. In the case of landless population, we want to make sure that they're landless tenant farmers. They're not just landless people. There has to be some element of agriculture that is related. The next one is around environmental concerns. What we want to make sure, and what we're trying to capture here, is they are things that relate beyond the farm scale. So for instance, soil erosion is a production constraint because it impacts yield. So we would not have soil erosion in Module F. We cover that in Module P. However, the impacts of soil erosion at the environmental or community level, such as silting of waterways, clogging of dams, water that's unable to be used for other purposes, is an environmental consequence beyond the farm rather than a production constraint. So think about, when you're answering this, does it affect everybody in an area, or most people in an area? And does it relate not just to yield, but to something else happening? Mackenzie, you've picked up a third common error.
Yeah, so in the production ceiling, it must be higher than your average yield, but it has to still be realistic. So we have an approximate yield gap there, and that will not let you put a value in which makes that more than 100%. So you should not be able to put a value that's lower, but make sure that they're not too high as well. The number should represent the yield which you would receive in a perfect year.
So no other production constraints
Yes.
or climate challenges. So for instance, here, the current yield in this data, the current yield for rice in the long season, as inputted in Module S, is 1 tonne. But then the maximum yield is 15.4 tonnes. So we think there might be issues with this sort of data. And we're seeing that because the current yield is 7% of the maximum yield. So if you're seeing numbers come here covered in red, really low numbers, maybe there's been a disconnect. Make sure that you're aligning with the correct crop over here, because there might be some numbers that have been inputted incorrectly. That's our review of common mistakes of Module F. All right, we are looking at common mistakes in the entry of Module P. So as always, we will zoom in if we're on a projector or on our screen. There's two things that we want to look at here, and this has changed a lot from the original PAiCE workshops. We're really trying to have clear definitions that go throughout the tool. So the first one that we've added recently, so if you're using an older version, you might not have this question, and this is the short name. Why we're using this short name is so that name actually transfers all the way through the tool. Instead of having non-specific names, that exact name will go all the way to the end of the tool. But we want that to be as short as possible so that our later screens don't have these really long texts that drop off in figures and graphs and everything like that. So we're putting a restriction that it has to be between 2 and 20 characters. So if you were to change that to something that was less than that, you will get a little error message that says short names need to be between 2 and 20 characters. If you're longer than 20 characters, try and think of a way to shorten that down, but they should still be readable and understandable to anybody else. So don't use code names with underscores or just an acronym like FF for flash flooding. You can still use the same name as you did in the subcategory if you want, but it should be the shortest name possible that allows somebody else that's not in your workshop to understand what that challenge actually is. Mackenzie?
So for the definitions here, we want to make sure that the definitions are comprehensive and that they're contextual to your actual system instead of a textbook definition. We know what these production constraints are, and we want to know how they affect your system.
So here's an example that we have, soil erosion, and then the definition, the process by which soil is displaced or removed from its original location, often due to wind, water, or human activity. That's what we would call a textbook definition. What we're looking for is what are the drivers of soil erosion, in this case in the Congo. Be as specific as you can so that we can use this in our literature, in our findings, to be a lot more precise and specific to context, not just with a textbook example. The other thing is, if you're using an older version, you might see a different set of subcategories that are up here. The important thing is that we want to be as precise as possible. So if you've had an older version, you might see disease, pests, and weeds all together in one. And what we've done is try to split them out because we want to be as precise as possible. So if you were to select poor disease control, again, this is a textbook definition: inadequate measures to prevent or manage plant disease, resulting in reduced crop health. What we want is a contextual definition that says the key disease issues that we have are striga, anthracnose, and something else. Actually name the key diseases that are there. The same with weeds, the same with pests. If it's pests, are you just talking about fall armyworm? Are you talking about other specific pests? Be specific in your definitions. In terms of the P module, which is the percentage impacted.
So for this one here, make sure that the percentages which you're putting in are logical and that they make sense to you at each stage. So if you have one crop that is affected by something that another crop is not affected by, please specify why this is the case in the explanatory notes. This will make it a lot faster for us to review this module, and it'll make it faster for us to actually get back to you with the data.
So it's saving us time and saving you time. If you're seeing red, please add discussion points or notes. Please do add those discussion points or notes. And as always, go into the results module for P, come in, look at these and think, are they logical? So in this example, is poor fertilizer use how we would think the number one production constraint in the area would be? Or is something that's coming down the bottom actually something that we think is more important? And if so, you're going to need to go back into your P module and look at what might be causing those issues. If you want to see it quickly, you can see a summary of all your data in the red P tab. That's the end of our review of module P. All right, welcome to our review of common issues that we're having in CV. It's not in CV, in module C. Starting with CV, as always, we zoom in. So there's a couple things to look at here.
Yeah.
Kenzie.
So just starting with the short name there, again, it'll be between 2 and 20 characters, and this short name will represent your climate challenge throughout the rest of the tool. So we'll not let you put less than 2 characters and not more than 20. The details here, again, make sure that these are contextual to your system instead of textbook definitions. And make sure that they accurately match the unit, which Brendan is talking about now.
Again, for examples like disease outbreaks, a sudden and widespread occurrence of high populations of insects, we'd like to know which insects you're expecting to worsen by climate change. If it's a current issue, it should be in the P module. If it's looking to get worse over the coming 10 years, then it's in the C module. Coming over to units, what we actually have, something Mackenzie has been working on, is a list of potential units that come under each of the different subcategories that you select. So this will be emailed to you now as well. The idea here is that we want to be able to measure this because we want to have some scientific rigor to what we're doing, but we also want to be able to, as climate scenarios change, actually update this. So if next year it comes out that we have a different climate scenario, what we could actually do is look at the data that you've put in and automatically update or do sensitivity analysis around that. But the key here is they should be measurable things. So for instance, in rainfall, so in flooding, you would want consecutive days underwater or consecutive days of waterlogged soil. These are measurable things. It's a number of days. In rainfall, it might be amount of millimeters in a particular day, or if it's a rain event, it might be the rainfall in one day, the highest rainfall in any one day. So we'll send this through and think about defining more clearly your units that are there. We also want to understand what's an expected value this year or in a normal year. And that's so that we understand the climate impacts. Maybe we're already expecting mild impact years. So we want to be able to know what's a normal number for that now. So in the case of insect outbreaks, what sort of percentage are we already experiencing so we know the impact of climate change beyond what's normal? As always, you've got your notes section, so please use the notes as well. If we move now to Module CV, and this is a particular area that I think we're picking up of concern. What we're asking here is that if it wasn't a perfect year for that particular climate event, what proportion of the area might be impacted? So the default here should actually be 100, and then count backwards from that. So an example here, the area that is in any way impacted when there are heat waves. The default would be 100, and then you think, what amount of area has something special about it that means it could not be impacted by a heat wave? For something like heat waves, I can't think off the top of my head what would be a mitigation there.
Yeah.
So the default is likely to be 100%. If it's a crop that just isn't impacted by heat waves, then it might be 0. So let's just say, hypothetically, cassava is not impacted by heat waves. It's very heat tolerant. Then maybe the number comes down because of that crop. For instance, flooding. What proportion of the area would never be impacted when floods happen? So that might be particular highlands that aren't able to flood because water goes straight into the waterways and down to the lowlands. So you might want to think about highlands, midlands, and lowlands and how they're affected by flooding. In terms of drought, it might be irrigation. So if you have a guaranteed irrigation that is there even in drought conditions, then that might bring your number down from 100 to just the area that does not have guaranteed irrigation supply. Now, as we found in Egypt, that might be true because it's a completely irrigated dominant area where the water is coming from a completely different country downstream. And if it doesn't rain in Egypt, there is still water generally in the Nile River. But for most of the other locations, you have to think, if it's not raining, is the water still running in the river, or is that river stopped as well? But the point here is that the default really should be 100, and then think about what are the aspects of the area and that crop that could not be impacted if there was any form of climate event. Anything to add there?
Just use your discussion points and definitions again. If there is somewhere where maybe you think it looks a little bit low and it's not close to that 100% mark, just tell us why and we'll assess that later.
Again, you're saving us time, you're saving you time, because we're going to come back to you and say, we're not sure this number makes sense. And again, with data sources, so here just World Bank, if we could be a bit more specific on what the source is, a URL or a citation, so that we can actually go back and find that in the future as well. Moving on to CO, the really important thing here is to make sure that you're looking at the units. So we're talking about heat waves. How many of the next 10 years would we expect not to have heat waves? How many would then be under each of the scenarios? So you really need to read each unit. So for flooding, how many years would we not expect flooding? 2 of the next 10. How many would we expect 4 days underwater? Between no flooding and 4 days underwater, 4. Between 4 and 8 days underwater, 2. So really read those units and think about the number of years that fit in each of those categories. Remembering that if we get our units right, we can also ask the data teams that EIA has associated with it, and they may be able to provide some assistance there as well. And as always, we want your notes and your data sources. Your data sources just can be informed opinion of experts if you don't have a data source, but we need to put something in there. The same with our notes up here. So you can actually put notes by each one. You can say, we really didn't have any data to support this, or we did this or that. All right, in Module CV,
So a couple of things here. First off, let's look at the non-event years. So keep in mind that for these ones, they should not be the same for all of the climate-induced events. In some cases, they will be the same, but it's really very unlikely, if not impossible, that they'll all be the same. So what we want you to do here is think about an average year, and we brought across the yield so that you have that next to it, and think about how does this climate-induced event affect the yield, and if that were taken away, then how much extra yield would we have? And that will be different for each crop and each climate-induced event.
And that follows then through. What you really need to do here is look at the actual units. So don't just think, oh, it's a mild event year for extreme temperature at establishment. Actually look, okay, what would the yield be if there were 3 consecutive days above 40 degrees Celsius and all of the other constraints were still there? So the key issue that we are seeing is that in module F, you're telling us the maximum yield under perfect conditions, this number. This number is not the same as the number that you put here, because in module F, it's if there were no constraints to production. In module CI, it's that there are all the constraints to production are there except the one that we are talking about. So in the first line, it's all of the other constraints are there as normal, except that there is no dry spell at establishment. So they're very different what you put in module F to what you put in module CI. What you then need to do is look at the exact units. What would yield be if everything else was the same except there was 5 consecutive days without precipitation? 7, 10. So these numbers really should be different, as Mackenzie says, because you've got everything else the same except for one change. And that scales down. So really, these numbers are really unlikely for the same crop to be the same each time. And finally, there is a little glitch in the macro, and we all know that it's not ideal that we're in Excel, but sometimes you will see graphs that look like this, where there is just a number 1 and random lines. There's something that is going on that I cannot change with code. What you need to do is click on that graph, go across to, click on the graph and go across to chart design and click switch row and column, and that will fix it up. For some reason, it just randomly changes the axes there. And that might also happen over in the prefill. You can see again, we've just got 1 on the axis. So click on the graph, go to chart design, click switch row and column, and that will fix it up. Unfortunately, there's nothing I can do. It's completely random why that's occurring. As always, we want to look at those results. Do we think that dry spell on maize is the biggest issue, climate issue that we have? And the same in the prefill. This is something where you press Control P. It is click off that graph and Control P. It's set up to print those 4 pages that you can email to people before your workshop.
All right, so here we're talking about module A-. And the first thing we want to touch on here is just the short names again. Again, same as the last ones. We just want a short name between 2 and 20 characters to represent the adaptation strategy for the rest of the tool. Make sure that it's logical and that everybody will be able to identify which strategy we're talking about with the name. Next, in the definitions there, we want to make sure that first and foremost that all the different definitions fit the tool. So you'll have your adaptation, where we go? We got the categories and the subcategories there, and we want to make sure that they are in line with what you've chosen, and then that they fit the rules up the top there as well. PAiCE works best when the adaptations meet the following criteria. Make sure that they all meet those criteria, please. The other thing with the definitions is that they need to be specific. So for varietal change and crop diversification, for instance, we need to know which crops you plan to use for this adaptation strategy. If you say varietal change and you just say what you want the varietal change to do, as opposed to giving us the actual variety, then it doesn't actually work with the tool. Same with crop diversification. If you give us an adaptation strategy which relies on crop diversification like intercropping, we need to know what intercrop you are planning to use with the tool so that we can assess the yields on a per crop basis.
So in the example here, where the short name is crop rotation and then growing different types of crops in a sequential manner, at the end there's thus groundnut with maize. We would want this short name to be replacing maize with groundnut, because that's the short name that we will answer later. And the last one is around the varietal change. So we want to have the actual variety that is there, because this is not a hypothetical. It should be variety BH400, or the actual name of that varietal change there. And that's because this is not a hypothetical. If we go back to our tool guidance, the adaptation has to be real, has to exist. It's not a hypothetical. So it's not breeding new varieties, because those varieties don't exist. We don't know how they can perform in a changing climate. In line with that, and if you have an older tool, you won't have this, and it's the year that farmers could first adopt on their own farms, excluding on-farm research. That the maximum that can be is 2025, i.e. next year, to cover things that are ready to go but are being released on the market next year, for example. But we're not breeding for a variety that's going to be available in 5 years, because that's a hypothetical and we don't know how it actually operates. So the maximum year that you can put in there is 2025.
Yep, so the last thing that we want to touch on is just how many adaptation strategies you're giving to each group. Because of the time that it takes to accurately assess each strategy, a maximum of 5 adaptation strategies per group is really all you will have time for.
That would be our suggestion for what you would be planning to get to. So we can see in this Ghana example, I haven't run the workshop yet, but we can see that there's 34 different adaptations across 4 groups. So you'd say that that's a very ambitious work plan to try and get that sort of assessment done. Remembering that if you can list 34, you can list up to 40 different adaptations here, but you have the ability to say that they were non-priority. So if you've got to cut some, you can list them as non-priority, don't just delete them, or they were incompatible with the criteria. Again, the criteria being listed here. So the final thing that you want to do as you set this up is allocate between however many groups you intend to have. The group can accommodate the tool can accommodate up to 6 different groups, plus the ones that will not be evaluated if they're incompatible or non-priority. When you get to the end of this, it will allow you to go to this page. This is the point where you want to save your file, close it, and then duplicate it into however many groups you have, naming it group 1, group 2, group 3, group 4 in the file name, and then reopen them and come in and select the group that you are assigning each file to. And that's the point there when you will go on with the workshop. So once you're done here, and that's usually where this will be emailed back to Mackenzie and I, and we'll do a final check. We'll say these are the things you need to change. Okay, you've done that, you're good to go. That's the point where you would then save it, duplicate it, and then set up for your workshop where each group selects that and then goes ahead.